Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
All right, so next up, hailing from the Big Apple, we have New York University, part of the Interactive Telecommunications program, and they will be talking to you about Bobo.
Hi, I'm Carolyn Concepcion.
I'm Adarsh Kusuru.
I'm Joy Lee.
I'm Haley Zhang.
And we're with New York University's Interactive Telecommunication program. And we would like to introduce you to our latest invention, Bobo. Bobo is a research tool designed to detect early detection of autism to transform a child's future. It is designed as a sensory system, including a toy, a mobile application, and a web application. We all know someone that's been diagnosed with autism, and it is a leading child developmental disorder today. Autism appears in the first 3 years of life and affects the normal development of the social and communication skills. Autism affects 1 in 68 children. On average, it costs $2.4 million to support an individual dealing with autism, and it is costing the U.S. society $137 billion annually, a threefold increase in less than a decade.
Autism is one of the most misdiagnosed disorders in children due to the length of time it takes to receive an official diagnosis. The average age of diagnosis is still over age 4, even though diagnosis can be done by age 2. The average lag time between an initial warning sign and diagnosis is over 13 months. By this time, the child has missed the window of early intervention services. These services ensure that the child's future well-being. Jack, one of the parents we spoke to, whose child was diagnosed at the age 2, creates early intervention services as one of the main reasons his son, now age 5, is off the spectrum and is attending regular school.
Given the positive impact early intervention can have, we were confronted with the following design challenges. How may we reduce the time spent in detecting autism? And how can we improve the accuracy of the diagnosis? How may we rise to the challenge to design for billion sensors to create life-changing technologies?
We began tackling our challenge by first researching how the current diagnostic process functions. We learned that there are no medical tests for diagnosing autism. A diagnosis is achieved by behavioral observations. It can take up to 5 different medical professions to receive an accurate diagnosis. The signs doctors look for are repetitive behavior such as stimming, avoiding eye contact, and communication challenges. We looked into research groups that are using technology to detect autism. For instance, Dr. Karen Pierce at the University of California used eye tracking technology to determine gaze patterns in infants. Jordan Hassemi at the University of Minnesota developed a computer vision system to identify body movements that could indicate autism. We looked into toys are used to treat children already diagnosed with autism. Auti is an interactive toy equipped with sensors that teaches autistic children positive behavior. Keep On is a miniature robot that motivates social interaction and responds to petting and squeezing.
We saw that there are diagnostic tools and treatment toys. We think there's an opportunity to bring the two together to create a diagnostic toy that makes children comfortable and gives doctors the information they need to make an early diagnosis.
To that end, we created a working prototype, Bobo, which we hope you can see later at Demo Fest. Bobo is a research tool that aids in the early detection of autism and consists of 3 things. A toy which tracks behavioral patterns in children commonly autistic children commonly, a mobile app that informs parents of toy interaction, and a web application to record, analyze data.
This is Dr. Perry. He's a child psychiatrist from NYU Medical Center. He's specialized in detecting child developmental disorders. He was the subject matter expert for us throughout our research. And now let's walk through a hypothetical scenario of how he might use Bobo. Today, he's meeting with new patients, Laura and Timmy. Laura is consulting with Dr. Perry because she has noticed that Timmy is not very social and lagging behind in his speech. So Dr. Perry observes Timmy for 2 hours and looks for signs of autism. For a more accurate diagnosis, Dr. Perry prescribes Bobo to Timmy, and he would like to see how Timmy acts in his home environment. He also explains how the mobile app tracks and visualizes Timmy's interaction with Bobo, and that he will be reviewing Timmy's behavioral patterns via a secure web application. So, Laura and Timmy take their new puppy pal, Bobo, home and play with him for the next couple of days. Timmy gets excited, picks up Bobo, and pokes him around, and discovers that Timmy sings to him, talks to him, and even tells stories.
So while Timmy is playing with Bobo, Bobo has a set of sensors that are designed to track autism symptoms. When Timmy rolls Bobo, the accelerometer and the touch sensor understand what type of motion Timmy is performing. The Bobo app allows Laura to see how Timmy has been playing and for how long. Bobo also has a set of cameras that track Timmy's eye gaze. We wrote software that tracks where a child is focusing his eyes. Each green dot shows where Timmy's eye gaze is. Lastly, when Timmy interacts with Bobo, Bobo also records Timmy's responses via the microphone and speakers in his mouth and ears. After a few days of observation, Dr. Perry observes that Timmy does not respond to Bobo when his name is called. He also observes frequent repetitive behaviors, and that Timmy's eye gaze is often off-centered. Most of the times, his eye gaze is around his mouth.
By studying the data from Bobo, Dr. Perry is able to confirm his assumptions and diagnose Timmy with autism. Due to the quick and early diagnosis, Timmy will now begin early intervention services.
As you can see, the Bobo system creates a seamless stream of communication between a child, a parent, and a doctor.
The reality is that to bring Bobo to life, there are a set of challenges. Issues around data collection, clinical testing, and getting adequate funding to build Bobo.
That said, we're still motivated and excited by the future possibilities Bobo can afford. We imagine building the set of sensors modular so it can be embedded in all kinds of toys to attract different children. The aggregated data will help global research efforts by creating new information sources that researchers can tap into. We believe that our approach can also be used in other developmental diagnoses, such as ADHD.
We believe no more children to suffer from the misdiagnosis of autism. Bobo imagines a world where kids like Timmy can see a future differently. We hope you will join us on the mission to create life-changing technologies that make a lifetime of difference. Thank you.
Thank you.
Excellent. Thank you, guys. And again, I just want to say that the audience is free to participate as well if there are any questions or comments. But otherwise, we'll go to our critics.
So this is a meta comment. I think it's really worthwhile to take your presentation in the context of what we saw from Israel and with the tilt board and with the first presentation from Denmark. Because at one level of abstraction, you're all doing this, it's the same presentation. I mean that in the most constructive, positive way. But what it illustrates collectively, because not everybody in this room is a designer, is that there is a methodology, there is technique, there is a profession that takes a specialized, with specific skills of how you approach, and the commonality of approach, of how you went to experts and how you did this. You're properly trained, and you did a really good job. The thing I really, I think reinforces that is just that this is not a topic that I would have expected you to know anything about before you started. You are working in the, you're in particular working in an area that is this child of the traditional classical industrial design, and you've brought that to interaction design. And I'll just finish with this and saying, you captured in this. You articulated your design brief, or you restated your design brief in 2 points, each of which was measurable. When we talk about design, in industrial design, how do you know you succeeded? And you articulated your brief in a way that you could always measure where you were in a controlled experiment way, in a way that follows in some sense what an engineer could understand as well, but with a very different methodology. This is really important, and I just congratulate you on having that just razor sharp vision and use that technique like just professionally. Thank you.
I'm going to build on what Bill said and said you are properly trained. And my favorite moment was Carolyn,
Yes.
when you came forward and you stumbled. And what did you do?
Keep going.
You took a deep breath and you kept going. It was beautiful and something that everybody can learn from. This is human. This is normal. It made you real, right? It made you a very real person and addressing a very important and real problem. You did a wonderful job going between each of you. That was very incredibly smooth and professional. And I could see you, I could envision you 10 years from now with a new product or perhaps this product. And that was lovely to see. Thank you.
It's a huge relief to me to hear that you're properly trained. And I concur. This is actually my first time seeing this presentation, and I'm sitting here delightfully pleased. And one of the things I want to ask you a little bit about is you talk about the toy as a diagnostic tool. And the situations you've got it set up in are, again, very noisy situations because you never know what's going to happen, whether the kid's even going to like the toy. Can you talk a little bit about the interviews you did with the doctor you were working with and what kinds of maybe more structured play you had in mind in order for the toy to work most effectively in diagnosis?
Joy, you want to take that? Okay. Well, I'll take that. So we'll use Dr. Perry, who is a doctor, a child psychiatrist at the NYU Medical Center, and he is a leader in the industry, and he was really excited to have a chance to speak with us about even the conversation of including technology in the autistic diagnostic process, and he was just really open to it. He said, this can really work. He was positive about the possibility of this being a reality, and gave us some really good feedback on what the senses should test, and the professional insight that we learned from him about the actual process of diagnosing autism was really helpful with our design process, and really taking that into consideration and how the toy can play, and how the main thing he told us is that the toy needs to allow children to show representational play, which means how does you show a normal way that a child can play with a toy, and how is it not invasive to the child? So I hope that answers some of your questions.
And to add on that, Dr. Perry was specifically concerned about making the system modular so it gets appealing to different children. And besides that, he wants to be able to collect data that's abstract from like a pure observation or video recording. So he was very open and excited about the dashboard part where doctors can get to view aggregated data. Yeah.
Any other comments? Wonderful. Well, thank you guys. It was great. That was Professor Lige Ann Hudson with that. Oh, there she is. Thank you. Sorry for mangling your name.